as we continue practicing angle algebra in transversals and in triangles, I figured we could see an example of some angle algebra that uses those two things together. This picture can look really confusing, but it's only two things, or maybe three things in one picture. First, I see this triangle over here with a blue line, a red line, and a black line. Then I see the two parallel lines, one red transversal, one black transversal. I'm going to try to use the colors to help us understand this more. Now, with just this information, my triangles, my parallel lines, and the transversals, we're going to find every single angle in this video. So, let's start by finding x. I see 64 here, 33x over here, and 25x over here. I know that these three angles together, they make a straight line, which means that they have to add up to be 180. So I can set up an equation for that. I can say 64 plus 33x plus 25x, that should all equal 180. Next, I can combine my x's together and bring everything else down. So the 64 will come down. 33x's plus 25x's gives me 58 plus 58x. And I just bring down this equals 180, equals 180. Now I want to get the x all by itself, so I'm going to start by taking away the 64. I'll do minus 64, minus 64, cancel those out. I'm left with 58, and I bring that down. 58x equals 180 minus 64. 180 minus 60 will be 120. 120 minus 4 should be 116. Let's double check that just to be sure. 180 minus 64, 116. Now I have 58 times x, so I need to divide by 58. Divide by 58. If I do it to the right side, or sorry, if I do it to the left side, I need to do it to the right side. Divide by 58. 58 divided by 58 gets me 1x equals 116 divided by 58. It's a really nice number, but I'll just prove it to you. 116 divided by 58, 2. If 1x is equal to 2, that means I can just say that x is 2. But my job wasn't just to find x, I wanted to find every single angle in this diagram. So if x is 2, I'll write that up over here. X equals 2. Well, that means I can put 33 times 2 to find this angle. 33 times 2 is 33 times 2. That is 66. So I know that this angle over here is actually 66. 25 times 2, 25 times 2 is 50. So I know that this angle is 50. Good. We're starting to get there, right? We have 3 of the angles in here. All right. I see the 64 here. I see a parallel transversal with the black line. This is my alternate interior angle. If I have 64 here, that means I have 64 over here. Now I'm going to start using these hash marks. So I already have a single hash mark here to this single hash mark, so I got to use 64 to 64. This angle over here is 64 degrees. Similarly, I'll do a double line over here. If this angle is 66, wait, I almost got caught by that trap. You got to make sure. I was almost going to do alternate interior angles from here to here, but this angle going from the black line to the red line, that's not the whole angle. I've got to continue all the way over this way to get the alternate interior angle to this guy. So I couldn't say that this angle is 66. Instead, it has to be both of these together. 66 plus 50 is 60, and 50 is 110 plus 6. This has to be 116. Once I've got the 64 and 116, I can use vertical angles to fill out the rest over here. 116 and 64, because my vertical angles are equal. Great, I've got all that over there. Let's switch to red. We can start dealing with this red transversal. Well, I know that my 50 here is the alternate interior angle to this right here. So that's got to be 50. Oops, sorry about hitting the mic. I'll use one red hash mark there to match up with the one red hash mark over here. Well, if this is 50, that means my opposite angle over here should also be 50. Not my opposite, my vertical angle. Sorry. This should also be 50. Okay. Now, I could use supplementary angles to get this. If this is 50, this whole thing needs to make 180, these two together. So 50, that means this will have to be 130. I can also check that by saying, hey, this angle over here is 64. This angle over here is 66. That's the alternate interior angle to this. So I'm going to put two red hash marks over here. This picture is starting to get kind of busy. 64 plus 66 is 64 plus 66, 130. And that makes sense because I have 130 over here. Notice this is an alternate interior angle to this whole part over here. This whole part over here is the alternate interior angle to my 130. I can now do another vertical angle. I get 130 over here. And in fact, this just becomes filling out the rest of my vertical angles. I've got this black line and the blue line, which gives me that 64. So that means I know that this is 64. Similarly, this blue and this red line, blue and red, I've got 50. So this vertical angle is going to be 50. Finally, this 66 matches up with this vertical angle. So this whole thing should be 66. But I have these two angles over here. It was bisected into two equal parts. That's what this one dash matching with this one dash means. Well, if the whole thing is 66 and I have two parts that make it up and they're equal, I need an equal thing that's equal to two equal things that when I add them together, they make 66. Maybe you can do that in your head, and that'll get you 33 and 33. Or if you need to do the algebra, I can just say, well, 66 is equal to two numbers that are equal to each other added up. So maybe y plus y. This could be y, that could be y. I know they're the same thing, so they can be the same variable. This would become 2y equals 66. Divide both sides by 2, and I find that y would be equal to 33, which is exactly what we saw. So this whole type of question, there's a lot going on, but any small little part that you do is actually not that crazy or difficult, right? You just do alternate interior angles, vertical angles, maybe add up the supplementary line over here. I also could have figured out, all right, I had 66, 64. Maybe I could use the three angles inside of a triangle to add up to 180. There's lots of different things to do here, which makes it seem like it's difficult. But really, you just kind of need to use a lot of space, make sure you write things down and take it slow. And it's not that difficult of a problem. It just looks really scary. Anyways, I hope that helps with some transversal and angle algebra problems.